All right, today we're going to pull back the curtain on a piece of technology that's, well, it's kind of everywhere and nowhere at the same time. It's one of the most essential and yet most invisible forces in our digital lives. Yep, we're talking about C++.
Think about your day. Every time you talk to an AI, get lost in some huge open-world video game, or even just stream something online, you're interacting with these amazingly complex systems. But what you see, the part you touch, that's just the surface. Underneath it all, there's a common, ridiculously high-performance engine making the whole thing go.
So here's maybe the best way to think about it. You've got popular languages like Python or JavaScript. Think of them as the steering wheel of a car. They're user-friendly, pretty easy to get the hang of, and they let you point the car where you want to go. But C++? C++ is the engine. It's the raw, powerful, incredibly complex machinery under the hood that's doing all the real heavy lifting, giving you that mind-blowing speed and performance.
And that is exactly why we call it the silent titan. It's kind of like the dark matter of the software universe. You can't see it, but it's the gravitational force holding so much of our digital world together. And, while it might feel like some ancient language from the 80s, it's not obsolete, not even close. It's foundational.
So where exactly is this titan hiding in plain sight? Let's go on a quick tour of some of the most high-stakes industries out there, places where C++ isn't just a good option, it's pretty much the only choice.
First up, the AI revolution. You always hear that Python is the language of AI, right? Well, that's really just a user interface illusion. When a data scientist uses a framework like PyTorch, they're basically using Python as a convenient remote control for a massive C++ engine that's doing the actual work. Trillions of calculations on the computer's graphics hardware, the GPU.
Okay, next stop, the crazy world of high-frequency trading. In this arena, you're not just competing against other trading firms, you're literally fighting against the speed of light. A delay of just a few microseconds, not milliseconds, microseconds, can mean millions of dollars in losses. C++ is the only language that gives you the raw bare metal control you need to bypass the computer's operating system and talk directly to the chips, shaving off every last possible nanosecond.
And yeah, the market absolutely knows how valuable this skill is. This number isn't a typo. It sends a pretty powerful signal. Top C++ developers in finance can pull in salaries well over $500,000 a year. And the reason is just simple supply and demand. There are very, very few engineers who can truly master a machine at this deep, fundamental level.
And of course, you've got the $200 billion gaming industry. Every single photorealistic world, every complex physics simulation you see, every massive battle with thousands of characters on screen, it's all powered by game engines like Unreal Engine 5, which are, at their core, absolute masterpieces of C++ engineering.
This quote just nails it. It really gets to the heart of what C++ does in gaming. It's not just telling the game what to do. In a very real way, it is defining the fundamental laws of that digital universe, from how gravity works to the way light bounces off a rainy street.
So that's the where, but what about the why? Why does C++ have this unbreakable grip on high-performance industries? Well, the answer is in its core philosophy. It treats the computer not as some abstract, magical box, but as a physical machine with real-world physical limits.
It all comes down to this core principle of zero-cost abstractions. It's like a two-part promise. The first part is, what you don't use, you don't pay for. Meaning, if you don't use a feature, it adds zero bloat to your program. The second part is, what you do use, you couldn't hand-code any better. So if you use a fancy feature, the compiler turns it into machine code that's just as fast as if you were a genius programmer who wrote it by hand. No hidden costs. And here's another huge advantage, how it handles memory. A lot of languages use something called a garbage collector that has to occasionally pause your entire application to clean things up. That would be a total disaster in the middle of a game or a financial trade. C++ uses a different system, often called RAII, which just means that resources get cleaned up instantly and predictably the exact moment they're not needed anymore. No pauses, ever.
And this is where you really see the kind of insane, granular control it gives you. Developers can literally design their own memory systems to make sure data is laid out perfectly for the CPU's fastest memory, the cache. They can tap into special hardware instructions to do a bunch of math all at once. They can even make promises to the compiler about how their code is going to behave, which unlocks optimizations other languages just can't risk trying.
But, and there's always a but, right? This ultimate control comes with a cost.
And that brings us to the central conflict in modern systems programming, memory safety. You know the saying, with great power comes great responsibility? And in C++, a single mistake can open up a major security hole.
And listen, this isn't just some academic debate among programmers. The pressure is coming from the very top. We're talking the NSA, the White House, major government agencies are now actively pushing the industry to adopt languages that guarantee memory safety right out of the box. And this leads us directly to the main challenger you hear about all the time, Rust. But it's really important to see this not as good versus bad, but as a fundamental difference in philosophy. C++ has a philosophy that says the expert architect knows best. It trades absolute guaranteed safety for absolute control. Rust has a different philosophy. It says the compiler will be your safety inspector. It trades some of that fine-grained control for a guarantee of safety. It's a choice the architect has to make.
So, does all this mean the Titan is finally about to fall? Is C++ on its way out? Not exactly. You see, C++ isn't some static relic sitting in a museum. It's actually in the middle of a renaissance. The real story here isn't about extinction, it's about evolution.
I mean, just look at this timeline. For more than a decade now, C++ has been on this rapid, 3-year release cycle. Each new version adds powerful features that have totally transformed the language from its older, notoriously complex form into a much more modern, expressive, and frankly safer tool.
And these aren't just minor tweaks. We're talking about game-changing, modern features. Modules are finally fixing decades-old problems with slow build times. Concepts are making one of its most powerful features way more user-friendly. And things like ranges are bringing in this really clean, modern, functional style for working with data.
So here's the real takeaway. The future isn't about replacing C++, it's about coexistence. Think about it. Massive critical codebases like Google Chrome or the Windows operating system are just too huge to ever rewrite from scratch. They are going to remain C++. But what we're seeing is that new, super security critical parts are being written in safer languages like Rust, and then they're integrated with that existing C++ core.
Which leaves us with this final thought. C++ isn't going away. In fact, it's becoming even more entrenched as the bedrock foundation that even newer, safer languages are built on top of. It's almost like the core of a nuclear reactor, immensely powerful, something you have to handle with extreme care, but ultimately indispensable. So the question is that its permanent role in our digital future?